lesson works on the application problems that involve radical functions or fractional exponential functions. So go ahead and pause and read the given information. All right, so we're working with a velocity equaling the square root of a, which represents the acceleration of the car, and r represents the radius of the curve. For the given information, they identify the maximum acceleration of 39.2 meters per second. So let's go ahead and let A equal the acceleration, so 39.2 will go in for A. Part B of this is 14 meters per second we give you is the velocity, so we're going to let V equal 14 in the equation, and what we want to do is find out what is the smallest radius. So our R is our question mark. So let's go ahead and plug it into our equation. So the velocity is 14, the acceleration is 39.2, and the radius is unknown. What we have to do is we have to solve this equation for R. So we need to get the R by itself. So we need to get rid of the square root. So to undo a square root, we're going to square both sides. So then the right-hand side of the square root and the square will cancel out. We're left with 39.2R on the left-hand side. And on the right-hand side, 14 times 14, or 14 squared, is 196. Now we're going to go ahead and undo the 39.2. So we're going to divide both sides by 39.2. To get the R by itself, the radius. So the 39.2's will cancel. We use our calculator. 196 divided by 39.2 is 5. So the minimum is going to be 5 meters for the radius of the curve. Part B, it says, what is the acceleration of a car moving at 8 meters around a curve with a radius of 2.5 meters? So we're trying to find the acceleration. So our A is going to be unknown. This represents our velocity of the car, and the curve, the radius is curve, is 2.5, so that's going to be equaling our R. So let's go down to part B. I'm going to make this a little bigger here. So we're going to use our same equation. The velocity equals the square root of the acceleration of the car times the radius of the curve. So we did identify up above that the velocity was 8 and the radius is 2.5. That will plug into our formula. So we're going to let V equal 8. A is our unknown, that's the acceleration of the car, and the radius is 2.5. So we have to solve this for A. So we need to isolate the A. So we need to undo the square root. So just like in part A, to undo the square root, we're going to square both sides. That's 2.5A with the square root. So undo it, we're going to square both sides. So 8 times 8 is 64. The right-hand side, the square root and the squared will undo each other. Now we need to undo the 2.5. So I'm going to divide both sides by 2.5. Now we use our calculators. So the A value is approximately 25.6 meters per second squared. All right, let's move on to the next problem. Go ahead and pause and read. All right, what's different about this problem than the last one is now we're not working with a radical formula. We're working with an exponential function. So in part A, air pressure decreases in altitude according to this formula. So P is your air pressure in pounds per square inch. We have 14.7, and then it's 10 raised to the negative 0.00014, and then the A value represents the altitude in feet above sea level. All right, so part A gives us, use a formula to estimate the air pressure. So our air pressure is unknown, and we want to find out if we give you an altitude of 5,280 feet. So this is going to be our A. So our P, our air pressure is unknown. They give us an altitude of 5,280 feet. We go ahead and plug in A into the purple equation and find our P, which will be our air pressure. So P equals 14.7, 10 raised to the negative 0.00014 times 5,280. Be very careful that you know how to use this with your calculator. So I'm going to go ahead and type this into my calculator. How PEMDAS works is it's going to multiply these two numbers first, then it's going to raise it to the 10 of that, and then multiply by 14.7. So go ahead and pause and see that your answer will become the same as mine. So you should get 12.399 pounds per inch. All right, part B says use the formula again to estimate the air pressure. So our P is going to be unknown, but now we're changing it to Mount Everest, and the altitude there now is 29,028 feet. So that's our A. So we use the same formula. I'm just rewriting the formula again. But now we're not going to substitute in the same altitude as in part A. Now our altitude, our A value is going to be 29,028. So now we substitute it in. This is going in for A. So P equals 14.7, 10 raised to the negative 0.00014, and we're multiplying that by 29,028. Go ahead and pause, enter it into your calculator, see if you get the same answer as me. So the air pressure now is 5.766 pounds per square inch. So again, my smartboard stopped here for a minute. So 5.766 pounds per inch.